So this is a boost converter. I will show you how it works, and I will also show you how you find the ratio between VO and VI here. So let's get started. So the way you need to think is what happens when the switch here is turned on and when it's turned off. When the switch is on, there will be just a wire here, like short-circuited. So this means that the current would go like this. It would not go through the diode because it would rather go through the short circuit, right? So this means that VI equals VL, okay? And VL equals L multiplied by DIL over DT, which is again equal to the numerical way of writing this, which is like this. So in this case, the time here, the change of time is when it's on. So we just write that, and the change of current when it's on is that value. Okay, so, and now what happens, so this is when it's on. So what happens when it's off? So when it's off, this one would be open, which means that there will go no current through here, which means that the current would go like this, around, like that, which means that VI is equal to VL plus VO. So, which we can simplify or change to do the same as last time. But now it's VL off, right? Over T off. And then plus VO. So what we want to do now is to compare these two equations, right? VI equals that and VI equals this. So what we know is that in steady state, the change of current when it's on, for the inductor when it's on, is equal minus the change of current in the inductor when it's off. Because if we draw a diagram here, when it's on, the current is rising, like this, and when it's off, the current is falling. And it goes up and down like this. So in order to make the average current that goes through the inductor here constant, and then all of these points needs to have the same current value, okay? Which means that this change up here needs to be equal to this change when it's going down. And therefore we can say that the change of current when it's on is equal minus the change of current when it's off. So what we want to do now is to solve the on equation for the change of current and the off equation for the change of current and put them into this last equation here, right? So let's do that. We should first start with on. So VI is equal to L and the change of IL on over the change of T on. So we can write the delta T on, the change of time when it's on, is equal to the duty cycle multiplied by the period, which means that this is equal to L multiplied by the change of time when it's on divided by the duty cycle multiplied by the time, the period. So if we move the L and the dt over, we would get IL on is equal to VI and multiplied by dt and then over L. So if we do the same for the off equation, we will get that VI VI is equal to L multiplied by the change of current when it's off over the change of time when it's off, and then plus VO. So here, the change of time when it's off is equal to T minus the time when it's on, which is dt. And this is equal to 1 minus dt. So we can put that in, and then we get L multiplied by the change of current when it's off over the change of time when it's off, which is 1 minus d multiplied by the period. And then we have to add VO. So if we move VO over to the other side, we would get VI minus VO. And if we now multiply by this on both sides and divide by L on both sides, we will get divided by L first, and then we multiply by 1 minus d over t. And this should be equal to the expression that we want, right? So we just put it here, the change of current when it's on, so L off, is equal to that. So if we put these two equations here into this equation, we would be able to find the voltage ratio. So let's start with the I on, which is now VI multiplied by dt over L is equal to VI minus VO over L multiplied by 1 minus d multiplied by t. So now the t goes with the t and the L goes with the L. Okay, so I forgot the minus here, which makes more sense. Now we can write this out as VD is equal to minus VI plus VO, right? And then multiply this by 1 minus D, like this. And we can rewrite the right-hand side as minus VI plus VID, and then plus VO multiplied by 1 minus D, right? So this means that this one here would go with this one here. So if we also move this one over, we get that VI is equal to VO multiplied by 1 minus D. So if we move this one over to this side and this one over to this side, we get that VO over VI is equal to 1 over 1 minus D, which is what we were looking for. Yeah, this equation here.